Okay, a hopefully brief video to demonstrate a test that Dennis and I have been trying to run in order to compare my model's behavior to the numbers he's getting on his sim. And I've run into something that I think Mike ran into with some of his testing too, and we can call it hysteresis or possibly something else. A little bit of background. Right now, the riser assembly is suspended from a scale, and the scale reading, if you can read it in the video, is at 4.25 pounds right now. And all water levels are at approximately 7¼ inches. And what we've been looking at is the behavior of adding air to the pod and first retainer gap, just to see the behavior of the layers for one, and what it takes to bring the riser assembly down to basically zero weight. And I come real close to that with 100 cc's of air, and I'm holding in my hand a 100 cc syringe, and I've been using that and reporting numbers based on 10 cc steps. And I'm going to do one fairly quickly, and I'll read off the numbers that I'm getting. Where we're running into a little bit of confusion is, and I'll go into a little bit more detail when I get to the 10-0-10 mark. So I'll just do this kind of quick. If I go to 90, it does take it a few seconds to stabilize, and I'm not going to completely wait for it. We're at about 3¼ or 3.24 pounds. And 80 at 2.4849. 70, 1.86, 60, 1.32, 50, 0.89, and it's climbing. Let it sit here for a second and catch up. It goes up to 0.93. It might climb one more hundredth. And 40 at 0.58. Now the interesting thing, and I can stop here and even demonstrate. I think we were at 0.96. If I bring this back to 50, it's going to go higher than that. It jumps right up to 1.2. And I can even let it sit here for quite a while. It really won't return to 0.96. When I get down to 0, I'll show you where I'm thinking part of this is coming from. So we'll go back to 40 at 0.6, 30, 0.3, 20, 0.13, 10, 0.6, and 0, 0.02. One thing to kind of watch, and this is where I'm seeing a little bit of a anomaly or behavior of the device itself. This differential right now is real close to ½ inch. This is on the outermost layer. And as I back off, we'll go back to 10. Immediately goes back to 0.17. This hasn't changed. And it'll take it several steps before it does. 20 now. And 30, and 40. I've taken quite a few data sets of these and reported them to the group. 50, and 60. And now we're still, I've taken 60 cc's of air out of the center section of the assembly, still have that ½ inch differential in the outer gap. At 70, still there. 80, still there. But it's just starting to shrink now. And 90. Now we're back to where we started from. And the last 10 cc's took the most out. And there's a little bit of variability here. I can't always get it to go exactly back. There's some wicking in these tubes. There's some other, residual in the assembly. We're working at such low numbers, it's really difficult to always hit it exact like a math model can. So now one more quick shot. 90, 80. Now this is what I'm seeing. This starts building fairly early in the cycle. 70. And it'll build steadily as I'm injecting air all the way through. Now I'm at 50, and we're already back at almost that ½ inch. And it won't change much. Now I'm at 40. And at 40, it's at the max it's probably ever going to get to. 30, and 20, and 10, and 0. More's happening here and here. Very little happening here. It actually dropped a little bit on that last 10 because I really am getting into a float condition. We're looking at only 0.03 of a pound reading on the scale. I think probably the last 20 cc's don't even really count, and that's the biggest indicator. So now I'll come back to 10 and 20 and 30 and 40, 50, 60, 70, 80, 90, 100. 2 full cycles, 100 cc's of air. It's pretty much back to where we started from. We're back at 4.32 pounds, and this differential is again at almost 0. It seems to build at a different rate than it diminishes. And the question now is that a key element of the system, or is that a byproduct of this build? Time for the answer.